All right, guys, we're going to go over factor form or intercept form as people call it. One more time because you guys are a little confused, so I want to clear up that confusion, all right? So, remember that intercept form is y equals a times x minus p and x minus q, where p and q are the x-intercepts. So in each form, you can tell whether or not it's going to be flipped up or down based off of A. A is the number that's in front of the form. So if A is positive, it's going to be opening up. And if A is negative, it's going to be opening down. Determine if the graph opens up or down. I'm going to model the first one. Okay? So, to determine if the graph is opening up or down, I need to look at my A. But Ms. Barnes, this one doesn't have an A. What am I going to do? Well, let me answer that for you. It does have an A. Even though there's nothing there, we must assume that there's a 1 in front because everything is technically to the 1 power, even if we do not put it to the 1 power. So we're going to have 1 right there. That 1 is positive, not negative, so we know that that is going to be opening up. All right, guys, let's take a look at number 2. Tell me what you think. Is it opening up or down? All right, well, let me take a look and see if you got it right. Since the opening number is -2, this one is opening down. All right, guys, for credit, I want you guys to do number 3. Tell me if it's opening up or down. What's your thoughts? All right, guys. Let's look at the axis of symmetry from intercept form. To find the axis of symmetry from intercept form, you must take a look at your P and Q. All right. Remember that in the general form of intercept form, there's always negative P and negative Q. So if you see them as positive, that means the number is actually negative. So what I do to remind myself is I take the opposite side that's in front of it. If that looks like a -1 to me, I know in my head that it's actually positive. All right, so the axis of symmetry formula for this form is P plus Q divided by 2. So I'm going to model how to find the axis of symmetry for this parabola. First, I'm going to label my P and my Q. And again, even though that looks like it's a -1, it's actually a +1. So P equals +1 and Q equals +5. I'm going to add my P, 1 plus 5, and put it all over 2 to find my axis of symmetry. 1 plus 5, that's 6, divided by 2. 6 divided by 2 is 3. So my axis of symmetry is 3. Remind you that axis of symmetry is the line that splits your parabola down the middle. So you want to make sure that you find the correct axis of symmetry because that's going to lead you to find your right vertex later on in this model. All right, guys, try number 5, and then I'm going to come back to you with the right answer. I'm sure you got this right, but let me show you anyway. I'm going to label my P and my Q. Again, even though that P looks like it's positive, it's truly negative. So P is -2, and that looks negative, but it's really positive. So Q equals +4. I'm going to do P plus Q divided by 2. -2 plus 4 divided by 2. That's going to be +2 over 2, which is 1. My axis of symmetry here is 1. All right, guys. This looks like a hard one, but I'm going to give it to you as an extra credit point if you could try it. Go ahead. All right, so let's talk about finding the vertex of a parabola after you found its axis of symmetry. So again, in order to find your vertex, you must first find your axis of symmetry. Make a mental note that if I need my vertex, I've got to find my axis of symmetry first. So I'm going to label my P and Q here. Remember that P looks positive, but it's actually negative. So that's a -5 plus a +3. I need to find my axis of symmetry, which is -5 plus +3 over 2, that's negative 2 over 2, that's negative 1. Actually, guys, what you need to know is that your axis of symmetry is actually the first coordinate of your coordinate point. That's your x-coordinate. So in your parentheses, you're going to have two numbers. Your first number is what you get for your axis of symmetry. Your second number is what you get when you plug in your axis of symmetry into the function. So I'm going to do negative 1 plus 5 and negative 1 minus 3. Negative 1 plus 5, that's 4. Negative 1 minus 3, that's negative 4. So your answer is going to be negative 16. That's what I'm going to put there. All right, guys, I want you to try this one, and then I'm going to come back to you with the right answer. All right, here we go. Then we get P and Q. P, Q. And make sure you note that it's a different sign. So that's negative 1, and that's actually positive 1. So negative 1 plus positive 1 over 2. Those cancel out to become 0 over 2. So your axis of symmetry is actually 0. That means your first coordinate in your answer is 0. Plug 0 back into the equation to get negative 4. 0 plus 1, 0 minus 1. Negative 4, 1, minus 1, negative 1. Negative 4 times 1, that's negative 4 times negative 1, that's positive 4. So you're going to plug positive 4 here, and that's going to be your final answer. All right, guys, get number 9 and go. All right, I'm going to show you how to tie that all together to make the perfect. Oh, where'd I go? All right, we want to tie that all together to make the perfect parabola on a graph. So start with your axis of symmetry, right? So find your axis of symmetry, you need to label your P and your Q. P, Q. Remember to use the opposite signs of what's present. So that's actually negative 2 plus positive 4 over 2. Negative 2 plus positive 4, that's positive 2 over 2, which means your axis of symmetry is 1. Since you have your axis of symmetry, you actually have the first part of your vertex. It's 1, comma. To find your second part of your vertex, you got to plug in your axis of symmetry in to the function. So negative 2 times 1 plus 2 times 1 minus 4. Now I'm going to simplify my parentheses because I'm doing pendas, so I want to do it in the right order. 1 plus 2, that's 3. 1 minus 4, that's negative 3. Negative 2. Negative 2 times 3, that's negative 6 times negative 3, that's positive 18. And then I want to find one more point so that I can make my perfect parabola. So if I got 1 here, then I'm going to choose the point of x equals 0. Well, first let me graph that so you guys can see why we're doing that. So my axis of symmetry on the graph will be a straight vertical line. I'm going to my origin and graph my vertical line at x equals 1. It's very important to graph your axis of symmetry so you can see exactly where the middle of your parabola will be. So either your parabola is going to go like that or it's going to go like that. We need to see where our vertex is in retrospect of our axis of symmetry. Now this graph is entirely too small to work with that big number of 18. So I'm going to scale it. What I mean by scaling is that instead of counting by 1 on my right axis, I think I'm going to count by 3 so that I can make it to 18. Let's see. 3, 6, 12, 15, 18. Perfect. My vertex is right at the top, 118. Remember, your vertex is going to always fall on your axis of symmetry. So if you apply a point that's not on your axis of symmetry, it probably ain't your vertex. Now I'm going to choose x value that's on either side of the vertex so that I can make a parabola. Because I need more than 1 point to make a graph. I chose x equals 0 because that's 1 away from where my vertex is, which is x equals 1. I'm going to plug in x equals 0 into my function. See, I replaced all the x's in my function with zeros. So now I'm going to simplify my parentheses. That's going to be 2, that's negative 4. Negative 2 times 2, that's negative 4 times negative 4, that's positive 16. So my second point is 0, positive 16. Remember, I counted by 3's on my y-axis. So that's 3, 6, 9, 12. Wait. Yeah, 3, 6, 9, 12, and then 16 probably be somewhere between that 18 and that 12. So I'm gonna put a dot there. Oh, on. And since I know that my parabolas are symmetric, I'm gonna also put a dot 1 point to the right instead of left on the other side of my axis of symmetry and make a parabola. The reason why I can guess that this one's going to be here is because all parabolas are symmetric, which means that if there's a point here, 1 point away from the axis of symmetry, if I go back to the axis of symmetry and go 1 point the other way, there should be another point that mirrors the point that I made, which is why I only needed to find 1 point, because I get 2 for the price of 1. All right, guys, I want you to try this next one. All right, then. First, you gotta find your axis of symmetry. But this looks a little wonky, right? Well, that's because there's not 2 parentheses like there was last time. But we can assume this x is in the parentheses because they're multiplying by each other. And if it's all alone, then we gotta assume that the p that would be in that parentheses is actually 0. And the q looks like positive 2, but it's actually negative 2. So I'm gonna do 0 plus negative 2 over 2. That's negative 2 divided by 2, which is negative 1. My axis of symmetry equals negative 1, so I'm going to go down to my graph and graph my negative 1. All right, then I'm going to find my vertex. Remembering that I already got my first point, so I just got to find my second one. So I'm going to plug in negative 1. So negative 1 times negative 1 plus 2. That's going to make it positive 1. Negative 1 plus 2, that's positive 1. So my second point is 1. So my vertex is at negative 1, 1. To find another point, I'm going to go 1 point to the right or left and plug that into my equation. So I'm going to go to x equals 0. At x equals 0, y equals negative 0, 0 plus 2. Well, there's no such thing as negative 0, so that's just 0. 0 plus 2, that's 2. But 2 times 0, that's 0. So this point is at 0, 0. The origin. If I'm going to go next, the next point should mirror this point. So I'm going to go back to my axis of symmetry and go 1 to the left instead. And that should be at the 0 as well. I'm going to make my parabola. And there we go. Easy as pie. Alright guys, try number 12 on your papers, and then I have an exit ticket for you to try to prove to me that you now know factored form. Good luck.